Hello. Here we will take reciprocal of trigonometric functions and utilize the cofunction identity. Okay. So reciprocal trigonometric functions are what? It's secant theta, right? Cosecant theta and cotangent, right? These are reciprocal trigonometric functions, right? So let's take a first problem as let us say that it's given to us that secant of 4 pi by 21 is approximately equal to 1.21, correct? And you need to evaluate cosecant of 13 pi by, let's say, 42. So that's your question, right? Now, since we know secant and we want to do cosecant, it gives us a hint that we should use cofunction identity, correct? Now, in cofunction identity, the sum of angles should become 90 degrees. Is it okay? Yes. Therefore, the whole idea here is to write 13 pi by 42 in terms of pi by 2 minus something and see if we get 4 pi over 21, then it is this value. So that's the kind of approach which we are trying to follow. So here, let's try to do the solution now here. So the approach here is to write this as pi by 2 minus something, right? We know that this is like in quadrant 1 because 42 half is 21 and this is less than 21, right? Graphically, I'll show you, it's very easy to do, but I'll do algebraically first. So it is in quadrant 1. So we can write this as 13 pi by 42 should be equal to pi by 2 minus some angle alpha or a. And we'll try to find what that a is. So say, well, a is from here equal to pi by 2 minus 13 pi by 42. Now to make common denominator, I need to multiply this by 21, right? So I get 21 pi over 42 minus 13 pi over 42. And 21 minus 13 gives me what? 8, right? 20 minus 13 is 7 and 1 more. So we get 8 pi by 42. Now this can be simplified. You can divide both by 2 and so you get 4 pi by 21. Correct? So 13 pi by 42 is 4 pi by 21. So we can now write cosecant 13 pi by 42 as equal to cosecant. I'll write 13 pi by 42 as pi by 2 minus a. And what is my a? A is 4 pi by 21. Okay. And using my cofunction identity, what is this equal to? Cosecant pi by 2 minus 4 pi by 21 is equal to secant 4 pi by 21. Which is 1.21, right? So which is equal to 1.2. So we get approximately 1.21 as our answer. I hope you appreciate the approach which we followed here. Okay. Now, graphically, we could have, thinking broad, we could have done it like this also. This is at conceptual level. Okay? I'm not making 42 parts here, okay? So what we have here is, we have 42 parts of our pi. 42 parts of our pi means that there are 21 parts in all here and 21 make 90, right? So 21 will make 90. There are 42 here, so 42 will make 180. Do you see that? And 21 will make 90. Out of this, if 13 pi is already taken, right? Let's say 13 pi is here. this is 13, right? These are out of 21 parts, these are 13 taken, right? So how many are left? 21 minus 13 is left, which is 8. Do you see that? So we get 8 out of 42 straight answer by just logically thinking about it and without really getting into intricacies of algebra. Okay, and that's a quick way of doing it. That's a beautiful way to answer multiple choice questions. I hope you'll really thank me for that. Okay, now that's one kind of problem. And now let's discuss another type of problem, deal with reciprocal trigonometric functions, right? Many of my students have been saying that normally when I give examples, they are very simple, like on sine, cosine, and tangent, and I'm not dealing with reciprocal functions. The concepts are same. See, it doesn't really matter whether I write secant, cosecant, or whatever. Do you understand? It's the same thing, correct? Now, let's take typical, where secant, cosecant makes difference, okay? Let's say that we know actually, and let's say it's given to us that secant pi by 6 is equal to 2 over square root 3. Now from this, you need to show that cosecant pi by 3 is equals to the same thing, which is 2 over square root 3. So we say this is given to you, and this is to show or to prove, right? This is to prove. Now how will you do this? Well, we can make a right angle triangle and then do it. So let's make one. That's our right angle triangle. And when we say that secant pi by 6 is 2 over square root 3, let's think that this is our pi by 6. Now what is secant? Secant is reciprocal of cos. That means secant is hypotenuse over adjacent. Is that okay? Yes. So hypotenuse becomes 2 for us, and the adjacent side is square root 3. Is that okay? Yes. And that's the right angle triangle. Now, in a triangle, if this is pi by 6, this is pi by 2, then how much is this? This, you know, is pi by 3. Correct? Now, so pi by 3 is okay. Now, I don't really want to add them up to show you, or should I? Okay. We say this should be pi by 2 minus pi by 6. Okay, let me do that also. Pi by 2 minus pi by 6. Okay. So if we make it common, that means multiply by 3, we get 3 pi by 6 minus pi by 6, which is 2 pi by 6, which is pi by 3. Is that okay? Okay. So we got pi by 6. Now when we say cosecant of pi by 3, then we are looking from this side, right? And cosecant is reciprocal of what? Cosecant is reciprocal of sine, right? And sine is opposite over hypotenuse. Therefore cosecant is hypotenuse over opposite side. And here the opposite side is square root 3 and hypotenuse is 2. So it's hypotenuse over opposite side. So you get your answer, same. Is that okay? So you write cosecant is news over opposite, right? And as you can see from a triangle, it is 2 over square root 3, the same thing. And that just proves us the cofunction identity for reciprocal trigonometric function. Okay? Thank you.